We know that cotangent can be written as cosine divided by sine. When we tried taking the derivative of cotangent, we rewrote it like this and used the quotient rule. Now trying to integrate cotangent, we can kind of do the same thing. We can rewrite it as a quotient, but we can't use the quotient rule because the quotient rule is for derivatives, not for integrals. But what we can do is notice that the derivative of sine is cosine. So maybe we can do some sort of integration substitution and simplify this integral. So let's try that. So we know that the derivative of sine is cosine, so let's let u equal sine. And taking the derivative of both sides with respect to x, we get that du dx is equal to the derivative of sine, which we know is cosine. So we get this. Solving for dx, we can multiply both sides of this equation by dx. And now we can solve for dx by dividing by cosine of x. And get this. So we solve for dx, so we can plug this in here for dx, and sine of x is u. So let's plug in everything. So we get this. So the integral of cosine of x stayed the same. Sine of x became u. The dx became 1 over cosine of x du. And now we can simplify. This cancels. This cancels. So we just get left off with 1 over u, the integral of 1 over u du. So what is the integral of 1 over u du? Well, we know that the derivative of ln of x is equal to 1 over x. This came from the derivative of e to the x. So the integral of 1 over u is just ln of u plus e. But remember, u is sine of x, so the integral becomes ln of sine of x plus c. So therefore, we can say the integral of cotangent of x is equal to ln of sine of x plus c.